gentlemen, allow me to introduce our next visionary who is a trailblazer in the world of DevOps. With an illustrious career spanning over 23 years, he is a research VP covering practices, technologies, and tools related to DevOps, SRE, cloud, automation, software engineering, and open source software. His expertise on a range of software engineering, security engineering, and platform engineering initiatives makes him the go-to person as an advisor for his clients. With a profound understanding of software engineering practices, he regularly guides his clients on how to apply these principles to infrastructure delivery, driving higher business value from cloud-enabled innovation. Our stalwart's professional journey in the tech world has been nothing short of impressive. In a remarkable feat, he was the first employee tasked with building the VMware AirWatch India operation, and under his guidance, he built a world-class R&D organization from scratch. The success of this venture culminated in the acquisition of AirWatch by VMware in 2014. He'll be gracing the stage today to take us on a thrilling journey through the top DevSecOps and SRE trends that are reshaping the landscape of digital innovation. With a wealth of practical experience and a finger on the pulse of the latest developments, he will undoubtedly provide us with invaluable guidance on how to thrive in the rapidly changing technology landscape. So, ladies and gentlemen, get ready to be inspired. Please put your hands together for the very dynamic Mr. Manjunath Bhat, Research Vice President at Gartner.
Good morning, everyone. Thanks for being here, and thank you for the kind introduction. So we'll get going. So my topic for today would be just bringing to light the top DevSecOps and SRE trends. And the key thing here is, these are not just technology trends. The way we look at these trends, essentially within Gartner, is these are the technology trends that drive innovation, right? So it's not technology for technology's sake, but it's really about harnessing the value of technology for driving business innovation. So imagine you're about to go on a long drive, right? What do you imagine? Like, you really picture yourself driving on an idyllic road. There's no traffic, right? You want to experience the joy of the journey. It's less about reaching the destination, but really about enjoying the pleasures of your journey. But guess what happens? This is the reality, right? You're faced with lots of traffic on the road, right? It's less pleasurable than what you expected. And this is no different, than DevSecOps today, right? So in many cases, this is really about the kinds of friction we face. There's less flow in the way we carry out our work. So in many ways, what you see here are a lot of bottlenecks on the road, but even in our own DevSecOps journeys, these are the kind of bottlenecks that would either impede developers from doing their best work, or in fact, bridging developers and operations together. Right. So the three trends, I've broken down this session into three sort of themes, right? It's not just a collection of arbitrary trends, but the way we should look at DevSecOps and SRE trends is through the lens of three distinct themes, right? The first theme is going to be about product engineering. So this is all about how products are engineered, how products are designed, how products are built, who builds them, right? What kind of practices impact. So this is all about engineering products. The second set of trends is going to be about platform engineering. So platform engineering, if you think about it, is really about creating platforms on top of which you build those products, right? So these are digital platforms that underpin products. The last is going to be resilience engineering, right? So it's not that resilience comes after you've built the product, after you've built the platform, but resilience is really, we like to think about resilience as a sort of a, it's not a synonym for reliability, right? So resilience encapsulates reliability, encapsulates, tolerability, encapsulates like recoverability, and in effect, it also sort of brings together, the underpinning of what Stephen just talked, right, which is security by design, security by default. So really, reliability, tolerability, recoverability underpinned by security. So let's get into product engineering, right? So the big trend that we're seeing under product engineering is what we call developer experience for short. Because guess what? Developers are at the heart of building new products, right? So why do you think developer experience has shot to fame? In many cases, right? So these days, if you look at the biggest challenge for organizations, it's not technology, right? It is about hiring the best talent, because even if you think of yourself, whether you're, let's say, one of the best banks in Southeast Asia, right, DBS, for instance, you look at, maybe you might be one of the best operators, Startup or Singtel, you're competing for the same kind of developer talent that, AWS is hiring, that Google is hiring. So developer talent is paramount. And how do you attract and retain good developer talent? That happens if you focus on creating the right environment for these developers, right? And so the key trend here is, how can you create an environment that fosters good developer experience? So we broke this down under these 3 pillars that you see. The first is going to be about improving their journeys. So all the way from onboarding to making sure, how can you create frictionless DevOps workflows, right? Like you saw on that slide, where you don't want a lot of bottlenecks in their way. But it's not just about, improving developer journeys, right? If you look at the central pillar, it's also about optimizing for creative work. So remember, especially with all the hype and buzz around generative AI, one thing that sort of disappoints me is we've sort of distilled what software engineers do to just code generation, right? And if you're a software engineer at heart, it should hurt you, because what the likes of maybe ChatGPT or Copilot has actually done is sort of said, okay, software engineering is all about code generation. Nothing could be further from the truth, right? So really what we're talking about here in the central pillar is, how can you optimize developers' time so that they focus more on creative work, right? So you eliminate a lot of the repetitive grind. So in fact, as we'll talk maybe in the second trend, that's really at the heart of how to put these automation tools together, right? So one of the third bullet you see here is, you can optimize for creative work if you take away all of the routine and repetitive tasks away. One of the other things, especially because we have a lot of leaders in the audience, is making sure that your teams don't go through the grind of a lot of unnecessary meetings, right? So making sure that you allow them to do deep work, and deep work requires a lot of focus time, right? So all of this actually helps optimize for creative work. The third pillar that you'll see here is about allowing or enabling developers to make a meaningful impact. So this is more than just doing their day-to-day tasks, right? Making a meaningful impact comes from the joy they feel in how they contribute to the community at large, right? So when developers do their work, right, making sure that maybe, you ask them, have you considered maybe contributing what you've built as an open source tool, right? Can you, it's not just about making an impact on your organization, but about making an impact on the ecosystem or the community at large. And in many ways, if you think about why developers bring their best selves to work, is because they feel that they're working for an organization that's just larger than themselves, right? So that's really all about making a meaningful impact on the community. And I've done this personally myself. If you look at the third bullet, it talks about how developers should get direct feedback from end users. In many organizations, you might have seen, developers are actually shielded from end users. That's the exact opposite of what we should aspire for, right? You put developers right in front of end users, let them appreciate how the product they're building actually gets used, right? So that's how you bring sort of, that's how you motivate developers. It's not through salary or perks or snacks and so on. So really, talking through the first trend of developer experience, you're also starting to see that, well, most people think that let's use metrics, right? So let's measure developer experience. This is another myth. You can't measure and quantify developer experience and sort of even create a synonym saying, okay, maybe a good developer experience means they are being productive, right? So this is another myth we want to dispel. So what we are also seeing, in fact, as maybe an unhealthy trend is, we're sort of trying to quantify and metricize a lot of software engineering data. This is exactly what is being shown here. So in many cases, if you're a software engineering leader, you really see, like, you might say, I have access to all of these systems and tools, and that's going to give me a lot of data. So I know what I'm doing. But guess what? If a business stakeholder, your business counterpart, and this happened to me on a call, right? I was on a call with a client in the Netherlands, and she said, like, I don't know if it's a dumb question, but I find it difficult to even answer a simple question as, like, what is my team working on? Have you considered, like, really asking as simple a question as that? If somebody were to ask you, what exactly does your team work on? How healthy is the team, right? How healthy is the product? These are simple questions which are very difficult to answer, right? It shouldn't have to be. So that's another trend we are basically saying is, and then the way we sort of try to address it, and what we recommend is, we've sort of put a lot of tools together. So we are seeing, like, and I'll try to bring this to life. So it's not just abstract and theoretical, right? So you can go purchase some of these tools, right? We have, as Gartner, we love markets, we love market categories. So we've created 2 market categories, what you see on the top right, which is software engineering intelligence platforms. So for instance, right in Australia, for instance, I'll take a lot of examples from our region. Logilica is one example of a software engineering intelligence platform. They're based in Sydney. So what they do is, they ingest a lot of this engineering data and then surface business insights, right? So trying to make it easier for software engineering leaders to answer that question, what exactly is my team working on? And the way you can sort of distill that essence is saying, you measure the work under these 4 categories, right? So you basically say, is the team helping improve quality, right? Are we going fast enough? By the way, on the topic of velocity, right? I'll make an interesting point. Most people in DevOps, at least in this room, we like to think that let's deploy faster, right? 10x more deployments means going fast, and fast translates to better. That's not exactly right. So the aim of DevOps is not to deploy faster. Our velocity, that is, this velocity of deployments, should match the velocity at which customers or users can absorb the change. That's true velocity, right? So if your users can't absorb, 10 changes per day, don't make doing so your goal, right? So it's not speed for speed's sake. So the other things you can also look at is organizational effectiveness. Those are business value and organizational effectiveness are really the kinds of value that value stream management platforms brings, right? So Dr. Niladri talks a lot about, like, it's not just about, like, technology, right? Are we harnessing, or are we actually creating value in what we produce? So value stream management platforms actually are systems designed to extract business value, right, from our products. So you might say, for instance, in this region, right, we come across PlanView, for instance. PlanView acquired another software engineering intelligence platform called TaskTop, right? So this is really how these kinds of tools get used. The other thing you might also want to look at is it's about measuring outcomes and not output, right? So one interesting trend you might want to take away is that try to make this switch from process and output metrics, because in most cases, right, when push comes to shove and you want to cut costs, you might say, well, what's my output looking like? But what you really want to do is, focus on what are the outcomes you're driving, right? Based on DevOps, based on SRE, is your customer satisfaction improving? That's the outcome you want to drive, right? If there's no change to customer sat levels, there's no point in deploying faster, in sort of meeting the technical requirements of DevOps, right? So you also look at, for instance, like at the bottom we say, our goal is not to optimize the flow of work, right? Our goal is to optimize the flow of value. I think this is a very interesting and a key takeaway. The next trend under product engineering, as it would be remiss of me if I don't bring up the idea of generative AI, right? So generative AI is obviously one of the biggest trends we've seen in recent history on product engineering. So while I also have to do the book ceremony, so I'll maybe use this opportunity to ask a simple question, which I think would be a cakewalk for many of you. Just speaking on generative AI, what was the name of the paper that led to this big transformation? Right? The whole idea of generative pre-trained transformers. What was the paper named, which launched in, which was written and published in 2017? I knew. Thank you, sir. Yeah. Yeah. So if you look at generative AI, right, in most cases, it starts with these key use cases, right? So I just want to highlight, I think there's another interesting takeaway from this, right? What you see today with generative AI is not what is the holy grail, is not how you should imagine that, okay, this is really what generative AI is all about, right? It's not about code generation alone, right? The way we would like to, you should reason, you should think of, what generative AI is capable of is, code generation is just the table stakes, right? Generating new code is really what the potential as it stands today. But in future, you're really looking at generative AI as maybe, in many cases, being able to shift left the whole idea of discovering problems on behalf of customers, right? That's another very interesting use case. In fact, if you think about more broadly, it becomes less about being a generation engine, but becomes more of a reasoning engine, more of a decision-making engine, more in fact as an automation engine. But all said and done, right? You're also looking at maybe not just the benefits, right? One of the big pitfalls of generative AI, and I don't know if you have seen this. I like to read a lot of academic papers, so you might notice that from my talk track. If you want to go back to maybe like the pitfalls of generative AI, right? Take a look at one of the papers that was written by Professor Bainbridge. I think she taught in one of the universities in the UK, and it's called The Ironies of Automation, right? It's a fantastic paper on like what the pitfalls of introducing automation too fast can be in your organization, right? It's not all smooth, because one of the key things Professor Bainbridge points out is when you introduce automation too quickly, too fast, what you're not prepared for is the loss of skills. If you look at the core, the downside of generative AI today is we basically say, it makes the job of developers easier because it generates code on your behalf. But guess what? Who's supposed to own that code, right? Who's going to debug that code? If there's a problem, who's going to troubleshoot, right? So when you deprive developers of all of the learning that happens through trial and error, and you give them a recipe to generate code quickly, you quickly lose all of the skills that would be needed to debug and solve problems when they're on their own, right? This is what happens even when pilots actually drive planes, but that's for another day, right? Now, generative AI is still very narrow use cases, right? What you see here is, I'm bringing this to life, and you might wonder, why is there nothing shown on the right side, the ops side? But this is exactly the reason, right? Because what you're seeing here is the state of the art as it stands today. There's lots of focus of generative AI on the left side of DevOps, which is on the development inner loop, as we call it, and very less emphasis on the ops side, right? So this is interesting, but like you'll see, right, for instance, it's not lost on the vendors. For instance, if you look at GitLab, and this is a public slide, so all of the vendor slides that I'll show is from public posts that they have made, so nothing confidential here. So if you look at this slide from GitLab, they're sort of taking a broader view of extending the power of generative AI, or you can think of this as their own version of Copilot, to essentially impacting every phase of the development and delivery lifecycle, right? As you can see, there is value in generative AI for also not just writing code, but detecting security vulnerabilities, right? Basically a use case that says, explain this vulnerability to me. That's GitLab's position, right? And then also further shifting right, you might say there's value of generative AI on the ops side. This is something that New Relic is doing, right? With some of the tools they're introducing, like Grok and others. Another example is from Harness. So if you look at Harness, this is exactly very similar, as you'll notice, to the previous slide, taking a much broader view of integrating generative AI, right, into every phase of the development and delivery lifecycle. This is actually a better way to think about it, rather than looking at generative AI as just impacting code generation. And finally, if you look at cloud providers, right, for them, the value of generative AI as a trend goes beyond just impacting the SDLC, right? So in fact, you can think about like the use of generative AI across technology domains as you'd like to see it, right? Which is, if you're using maybe Google, AWS or Azure, you might want recommendation engines that say, it would be nice like for an engine to come up and say, okay, here's how you can save costs, right? Here's how you can improve your sustainability. Those are the kinds of boilerplate repetitive use cases where generative AI can come in very handy, right? This is from Google Cloud, by the way. So speaking of sustainability, the third trend and the last trend under product engineering is going to be green software engineering, right? So here's some interesting kinds of conversations we have on the topic of green software engineering. So this is in many ways, like, I don't know, you might think when we talk about green software engineering, right, or sustainable software engineering, it's out of some altruistic attitude, right? We want to do good for climate. But based on a lot of our surveys, what we have found is that most organizations don't implement green initiatives out of the goodness of heart, right? I'll maybe count a few real reasons that have surfaced and which felt, they were pretty interesting for us. One is when people undertake green software initiatives, many times, right, it's one, right, for driving increased customer value, right? That's a nice one. So when I say customer value, customer satisfaction, you can think of this as organizations undertake green software initiatives so that it enhances, their brand reputation. It enhances their image in front of, their customers, right? So this is an interesting sort of reason for undertaking green software initiatives. It's not, saying, okay, let's reduce carbon emissions, right? Obviously, that has direct benefits, but there is an underlying, because there has to be an economic incentive for everything, right? So the economic incentive is how can we appeal to our customer base? How can we, in fact, appeal also to future talent? Because that's been another interesting driver for adopting green initiatives, which is how can we attract, better talent into our organizations? Because guess what? Developers like to work for organizations. They just think beyond, day-to-day or, quarterly revenue results. So the other interesting thing, that we are seeing is most people think, maybe digital and sustainability are mutually exclusive, right? But it doesn't have to be. What we have seen is digital and sustainability are actually, and in fact, mutually reinforcing transformations. That's been a profound revelation for us, because if you look at what the statistics show, right? What data tells us is, in many cases, 90% of our survey respondents, they basically said, digital technology is increasing their maturity in sustainability initiatives, and vice versa, right? Which is investing in sustainability also increases their own, digital maturity of the organization as a whole, right? So that, I think, is quite interesting. So it's not like, if you invest in sustainability, you're lacking any kind of sort of emphasis on digital initiatives. The second trend, we look at is platform engineering, right? So, in fact, platform engineering was all about how can you scale DevOps. So, platform engineering, by the way, is not a trend or not, an initiative you should use to introduce DevOps into your organization. So, platform engineering should always be about how can you scale the adoption of DevOps within your organization. So, what you see here is like, the classic adaptation of you build it, you run it, right? Which started with AWS. They said, well, if your teams have to go fast, let one team own it end to end. This is your classic food truck model, right? This is how food trucks operate. There's a food truck, it owns the entire supply chain, right? Everything from cooking to customer service, everything is done by the food truck. But guess what? This does not scale, right? So the analogy, the metaphor we'd like to use for platform engineering is one of a shopping mall, right? So think of the platform team as providing a shopping mall for your development teams, where you abstract away a lot of the infrastructure concerns, a lot of the utilitarian concerns. And so every shop becomes a development team in its own right, and they focus on their core competency, right? Which is delivering value to their customers. So this is an illustration of how the platform engineering initiative sort of evolves within the organization, right? So you go from left, where you have single teams, all the way, to the entire organization. And what you really see highlighted in orange is that you need platforms in order to scale DevSecOps, DevOps initiatives, or even SRE. And as a technologist, right, you really want to sort of bring this to life, right? So you might say, well, what does the platform team actually do, right? What do they deliver? So what you're seeing here is an example of capabilities that constitute internal developer platforms. So the output of platform engineering is going to be like their deliverable is an internal developer platform. And this is just a sample set of building blocks that comprise an internal developer platform. So the way you can think about this is that there are software development teams on the left, right, that consume the services offered by the platform. And essentially what you're creating is a paved road, right? So this is not like every development team goes about working in their own right. So you're creating a paved road for artifacts and for binaries to flow to production. And I think I'll maybe sum the value of platform engineering this way. It's at the heart of what DevSecOps is about, right? So what you're doing is you've decoupled what good looks like. You've sort of codified all of the practices, embedded it as part of the platform, so developers don't have to think about it, it just happens, right? So this is, I think, what Stephen was referring to as security by default. But yes, so I won't dive into too much details in the interest of time, but what you'll see here is providing a paved road doesn't mean that it's going to be effective for all teams, right? So there will be deviations from the paved road, so make sure that you account for them and sort of provide those, identify the deviations and evolve the platform itself. Another, last trend within platform engineering is the concept of developer portals. This is coming up a lot. So you will see that, what you're seeing here is a schematic of an internal developer portal, right? This is not to be confused with API developer portals, right? So those are external facing developer portals in many cases. But internal developer portals, in a nutshell, are about providing a window. So think of developer portals as a window that provides access to the internal developer platform capabilities, what you saw on the last slide, right? So this is an interface to the developer platform. The last section in this talk is going to be about resilience engineering, right? And resilience engineering, let's maybe relate to this in a better way, right? When we think of resilience, what comes to mind? Typically, it's all about outages, right? And even some of the best banks, in developed countries, right? So if you look at, these are probably the big 4 banks, among the big 4 banks in Australia, right? So the public tweets, that go something like, hey, we are currently experiencing an outage. This is at National Australia Bank. Now you look at Commonwealth Bank or you look at ANZ, right? Nobody is spared. So outages abound, right? So resilience is definitely key. And so one of the things you might think of is if these kinds of very close, as close to digital native as you can get, if these digitally native banks succumb to resilience issues, there's no escape, right? So we got to really build resilience from the ground up. This is not like, much like security, you can't add resilience as an afterthought, right? So we like to think about, and I'll provide a framework on how we think of resilience engineering, but let's use this as at least a very tactical motivation on why resilience engineering is important. And the other thing, I like to also emphasize this. By the way, this is something that's often underappreciated, right? So I just started off saying, to say it's tactical, which is resilience is important to handle outages. But that's not the key driver. So if you are maybe, a bank offering a service, you might want to say, let's treat reliability as a differentiator. That's a very different way of looking at resilience. So resilience then does not just become a way of handling operational concerns. So it's not an operational issue. This is something that becomes a key technical differentiator for your products itself, right? I find it surprising that even though we sort of take it for granted, like reliability should be a key differentiator, right? And I think if you look at it, it's obvious, and that's why we don't mention it. Most of the time, you'll find that you abandon a website if it's not loading. You never abandon services because they don't provide certain functionality. It's almost always a non-functional attribute that causes you to abandon certain services, right? So treat reliability as a key differentiator. And also another, incentive for resilience is as you move to the cloud, right? You can't take resilience for granted. Cloud does not translate and does not equate to resilience. There's a lot of work that we have to do despite being in the cloud, right? So these are some of the other reasons why, resilience is sort of, becoming increasingly important, right? So digital transformation actually you can think of resilience as being a prerequisite for digital transformation. So the more digital services you provide, it becomes even more important that those services are resilient, right? You're also looking at, for instance, like I mentioned, security, right? Security is a core ingredient of resilience. So how we think of resilience, right, is essentially, we basically think of it as digital immunity. So much like we say, we don't go to the doctor when we are sick, right? That's really like treating your symptoms. We got to build immunity from the ground up, right? So we think of resilience as building digital immunity so that you're better prepared, when you have, whether it's outages, whether it's security attacks, whether it's ransomware attacks, and so on. So building a digital immune system really requires these 6 pillars, right? So this is our framework for resilience engineering, aka digital immune system, right? So if you look right here, we like to think of this as starting with observability, right? And the reason is because and the reason is it's without observability you don't have data to solve other problems, right? So and that's the reason we basically say start with observability. In fact, shift left observability through techniques like observability-driven development, right? It's not just test-driven development, right? It's going to be observability-driven development. Because I don't have a whole lot of time, right, to go through each one of these circles, but I think, the way you can sort of drive a narrative out of this is start with observability so that you get a sense of what's happening inside your systems, right? Just looking at the outside characteristics. Look at quality not just as a shift left initiative, but as a continuous exercise. That's what continuous quality is about. Then embark upon chaos engineering, right? You think of, institutionalizing chaos engineering, chaos experiments. Maybe there's one quote I can leave you with from, I think it was from Casey Rosenthal, right? And where he basically said, like, why do chaos experiments if you're already doing testing, right? And something that stuck with me is when he said, tests don't generate new knowledge, experiments do, right? I think that's a very interesting way to outline the value of chaos engineering. You want to perform experiments because you want to generate new kinds of value, new kinds of data. And then auto remediation. And when you put all of these things together, it makes it easier for you, to implement SRE, right? So that's really what the digital immune system or resilience is all about. And finally, if you look at these 3 pillars of how you embed security within the platform, right? We say security by design and security by default requires securing code, securing pipelines, and securing your runtime, right? And if you want to ride the wave of all of these technology trends, right? Do read the book, Team of Teams by, I think, I can't get his title right, but his name is, General Stanley McChrystal, right? Fantastic book again, and where he makes this really brilliant point where if you want to look to the future, we are not looking at a future which is very predictable, right? Which is very stable. But instead, you're looking at a future that is rapidly changing, very volatile. And so keeping that in mind, the technology trends you embrace should not be about improving efficiency, but it's really about making your organizations more adaptable. Right? So therefore, make adaptability, not efficiency, your central competence. So with that, I close. Thank you for your attention.